Section 3.5. Solving linear inequalities. All right, so we've seen the word linear a lot in this class. What does linear mean? It means if you graph it, you get a line. That's correct. What does it mean in terms of an equation? If I write an equation down without graphing it, how will you know if it's linear or not? If it's in the form mx plus b, it would definitely be linear. It would definitely be a line. How else would you know? What if it's not in mx plus b form? For example, I'll write down some equations. You tell me if they're linear or not. 2x plus 6 equals 3x squared minus 5. Linear or not linear? Not linear. Why not? Because it's got an x squared in it. Okay? So this one is not linear. 4 over x equals 8. Linear or not linear? Here, vote for linear.
I mean, it has a y intercept and a slope.
No, I don't think this one does. I think this one is not linear. What makes it not linear? You can have fractions, but you cannot have x's in the denominator. You're going to have variables on bottom. So that one's not linear. So, if I just write down an equation in general, how do you tell if it's linear or not? Just by looking at it? What can you not have? That's the easy way to answer it. You cannot have exponents other than a power of 1. That's okay. So you can't have squares and cubes and halves and fourths and 3/8, things like that as exponents. What else can you not have? You cannot have x's in the bottom. And there's one more thing. I haven't written an example like this yet, but what else can you not have? What's that? If y is an even power, then you have something that's not a function. And it certainly would not be linear too, because it would have a y squared or a y to the fourth. That's true. This is the last thing you can't have. Can't have roots. You can't have square roots, cube roots, fourth roots, any of those roots. Okay, so linear means you don't have powers, you don't have fractions with x on bottom, and you don't have square roots, cube roots, fourth roots, so on and so forth. That's what linear means. What's inequality mean? We're not going to have an equal to sign. So what are we going to have if we're not going to have an equal to sign? We could have greater than, we could have less than, we could have greater than or equal to, we could have less than or equal to. So that's what we're going to have in this section. We're going to have linear things, but we're going to have inequality symbols in between. And we're going to solve them. Solving linear inequalities works just like solving linear equations. With one new rule. And what I mean by solving inequalities works just like solving linear equations. You can add numbers to both sides. You can subtract things to both sides. You can multiply on both sides. You can divide both sides, just like you can with linear equations. What's the one different rule? Anybody remember? The one different rule?
When you change the negative or positive sign, you switch the sign.
Okay, the one rule is if you multiply or divide by a negative number, you must change the inequality. That's the one different rule. So you can multiply or divide by a known number, just like you could with an equation, but if that number is negative, it causes something to change. And let's see why that's true. Give me two numbers. Anybody got two numbers?
4 and 8.
4 and 8. So if I write down 4 and I write down 8, would I put a less than symbol in between those two numbers or a greater than? 4 is less than 8, correct? So that would be a less than symbol. Now I'm going to take that and I'm going to divide both sides by, let's say I divide both sides by negative 2. What's 4 divided by negative 2? Negative 2. And 8 divided by negative 2? Negative 4. Which way does the inequality symbol go now? Negative 2, is negative 2 greater than negative 4 or is negative 2 less than negative 4? The inequality symbol has to flip to make it still work.
So, not right because of this?
What's that?
This is saying the answer is equivalent answer is wrong?
No, the answer is correct. This is just showing that when I start with an inequality and I divide by a negative number, the symbol in the middle has to flip. Okay? Let's start with two new numbers. How about one positive number and one negative number? Anybody got one positive number and one negative number?
3 and -9.
3 and negative 9. So there's 3, there's negative 9. Is 3 less than negative 9 or is 3 greater than negative 9? 3 is, I'm even going to use greater than or equal to. Is that still true? Is 3 greater than or equal to negative 9?
If you divide by negative 3,
Well, is 3 greater than or equal to negative 9? Yeah, that's true. 3 is greater than negative 9, right? This time, just to be different, I'm going to multiply by a negative number. So let's multiply by, let's keep it fairly simple. How about we multiply both sides by negative 2? What's 3 times negative 2? Negative 6. What's negative 9 times negative 2? Positive 18, correct? So which way does my symbol have to go? Is negative 6 greater than or equal to 18? No. In order to make it true, I would have negative 6 is less than or equal to 18. The symbol has to flip in order for that to be true. All right, so that's really the only rule. The only rule is, only different rule, when you multiply or divide by a negative number, flip the sign. Otherwise, solving linear inequalities works just like linear equations, which we've been doing all along this semester. All right, so let's solve a couple linear inequalities. Solve. 2x plus 1 less than 5. How would you solve that inequality? Subtract 1. When I subtract 1, do I flip my sign? No, why not? I'm subtracting 1. I'm not multiplying or dividing by negative 1, am I? So don't flip your sign there. 2x is less than 4. And then? Divide by 2. Do I flip my sign? No, because I'm dividing by a positive number. Answer is x is less than 2. All right, now, here's a little different thing. When we have inequalities, we actually write our answers in 3 different ways. So you're going to see 3 different answers. This is called inequality notation. So that's one way you'll write your answers sometimes. Sometimes you will be asked to show your answer on a number line. So you would draw yourself a number line. There's 0, there's 1, there's 2, there's 3, there's negative 1. All right, how do I graph x is less than 2 on a number line? Okay, I start at 2. And what symbol am I going to write at 2? An open circle. So I'm going to write a circle like that. And that's going to go left because it's less than 2, correct? So I should shade this way. That's how you would draw that. Now, why do we put an open circle? That's right. If this were less than or equal to, how would we indicate the equal to? We would fill in the circle. Draw a closed circle. All right? So that's inequality notation. That's number line. And then there's a third way that you'll be asked to show your answer, and that's called interval notation. So I'll put that up here. And here's the way interval notation works. You take your answer and you put the smallest thing on the left. What's the smallest thing? How far to the left does this go? It goes as far as you want it to go. So what symbol do we write for go as far left as you ever want to go? Negative infinity is as far left as we can go. So there's the smallest thing. Put the smallest thing on the left. That's negative infinity. How far to the right does this answer go? Positive 2. Positive infinity or negative infinity always gets a parenthesis. Always gets a round bracket. And in this case, the 2 will also get a round bracket. The round bracket indicates that you just have a less than symbol or a greater than symbol. What if I had a less than or equal to symbol? Then I would use a square bracket. Correct. So round bracket, open circle, less than symbol all mean the same thing. Square bracket, closed circle, less than or equal to would all be the same thing. Questions on that? All right, let's try another one then. How about 3x plus 4 is less than or equal to 5x minus 6, I guess is a good number. How would you solve that inequality? Add 6 to both sides, that's fine. And then? I'll add the 6 to both sides. 3x plus 10 less than or equal to 5x. Do what? Try to get both x's on one side. So I guess I would subtract 3x. 10 less than or equal to 5x. Oops. How about 2x? I was thinking ahead because I was dividing by 2. When I divide by 2, I get 5 is less than or equal to x. Okay, so there's my inequality notation. Here's my number line. When I draw number lines, I'm pretty lazy. The only point I really need to mark is the point 5. So there's 5. Do I put an open circle or a dot at 5? Closed circle or a dot. This time I get a dot because I have the equal to. Whenever you have an equal to, you put a dot.
How do you know if it's 5 to x? How do you know?
The original problem just gave the equal to. That's all. The equal to symbol was right there. On this problem back here, there was no equal to symbol given at the beginning. So that'll be given to you right in the beginning of the problem. All right, do I shade to the right or do I shade to the left?
The left. I mean the right.
The left, I mean the right.
The right.
The right? How come the right?
Because, no, actually, no, you do it to the right.
To the right?
I feel like I'm wrong now.
Feel like you're wrong now? You're not. You should go to the right.
Because x is greater than or equal to 5, so you should go from 5 up.
What kind of numbers are going to work here?
Anything bigger than 5.
Anything bigger than 5. Like 6 would work, right? If I plugged in 6, I would have 5 is less than 6. That would be true. If I plugged in 10, 5 would be less than 10. So you're right, you should go to the right. But I think we made a bad decision. On these problems, my personal opinion, it's a good idea to always put the x on the left. Because this symbol, 5 less than or equal to x, that will confuse people. People will say, it's a less than symbol. Whenever I see a less than symbol, I always shade to the left. And that's not correct for this problem. So my opinion on these is it's a good idea to always get the x's on the left. That doesn't mean you have to. You can do it this way. There's nothing wrong with this. You just need to recognize this, that this means x is a number bigger than 5, so we should shade to the right. So there's our number line. And then how would we write this in an interval? What's our smallest number? 5. What's our biggest number? Positive infinity this time because it goes to the right. Infinity always gets a round bracket. And in this case, 5 should get a square bracket because 5 has the equal to and 5 has the dot. The equal to, the dot, and the square bracket all go together. Questions on that one? All right, so how would this problem be different if we did it again and we put the x's on the left? 3x plus 4 less than or equal to 5x minus 6. So what would be different if we put the x's on the left? We would begin by subtracting 5x minus 2x plus 4 less than or equal to negative 6. Minus 4 on both sides. Minus 2x less than or equal to negative 10. And here's where the big change would come. This time you divide by the negative 2. And you got to flip. So you would write x is greater than or equal to 5. Okay, same answer, just written different. 5 less than or equal to x. X greater than or equal to 5 are the same thing. But now, if the x is on the left, then if you see the greater than sign, you do shade to the right.
What is it's a positive 5. It's still a positive 5.
It's still a positive because I take negative 10, divide it by negative 2. 2 negatives make a positive when I divide. Okay. How about, I'm just going to steal one out of the book here that looks kind of complicated. Minus 5 times 2x plus 4 plus 1 less than or equal to 3x minus 3. How would you begin solving that one? Distribute the minus 5 through. All right, minus 10x minus 20 plus 1 less than or equal to 3x minus 3. What's your next step? Combine your like terms. On the left-hand side, you've got a minus 20 and a plus 1. Minus 20 and plus 1 makes negative 19. So minus 10x minus 19 less than or equal to 3x minus 3. At this point, you need to make a decision. Are you going to put the x's on the left or on the right? My preference is to always put them on the left, which means I need to subtract 3x. Minus 13x minus 19 less than or equal to minus 3. Add 19 to both sides. Minus 13x less than or equal to 16. And then finally, divide by negative 13. My answer would be x is greater than or equal to Negative 16 over 13. Nobody ever promised the answers were going to come out nice.
So you said why did we switch the sign?
Why did we switch the sign? Because right there, what did I do? I divided by negative 13. Anytime you multiply or divide by a negative number, that inequality symbol needs to change. That was our one new rule about inequalities. You divide by a negative number, you flip the symbol. Number line. Again, with my number lines, I'm pretty lazy. There's negative 16 over 13. I only mark one spot. Circle or dot? Dot, because we have the equal to sign. Shade to the right or shade to the left? Shade to the right, because it's greater than. And finally, interval notation. My smallest number would be negative 16 over 13. Biggest number is infinity. Infinity always gets a round one. And in this case, negative 16 over 13 gets a square one. Because again, we have the equal to, we have the dot, you get the square bracket. Those three things always all go together. Questions on that? Okay, a couple more fun ones out of the book. I see some good ones here. Oh, I like this one. 5/8 plus 1/6 b is greater than 2/3. What do you do with a problem like that has fractions in it? Find the common denominator. Okay, so I look at 8, 6, and 3. What's a common denominator for 8, 6, and 3? 24, I think will work. 8 times 3 is 24. 6 times 4 is 24. So what do I do? That would work, but that's not what I would do. What I would do, 24 is my common denominator. What I would do is I would take each number and multiply it by 24. So I would take 24 and multiply it by 5/8. Plus, take 24 and multiply it by 1/6 b. And then take 24 and multiply it by 2/3. And I'm going to get rid of the fractions. That's correct. What you said get 24 on bottom of each fraction. That'll work, but then you still got fractions to deal with. My plan here is to get rid of the fractions and make my life a lot easier. So what happens when I take 24 and I multiply it by 5/8? Well, the big thing that happens is you have a 24 on top and an 8 on bottom. You can reduce. How do 24 and 8 reduce? Reduce to be 3. 3 times 5 is 15. Plus, same thing happens with the next one. I got a 24 on top and a 6 on bottom. That reduces to be 4, so that's 4b. Greater than 24 and 3 reduce to be a 8. 8 times 2 is 16. So anytime I have an equation or I have an inequality that has fractions, what I do is I multiply by the common denominator. And that makes all the fractions go away. And when all the fractions are gone, that's a much easier problem for me to solve. Subtract 15 on both sides. 4b greater than 1. b is greater than 1/4. Number line. There's 1/4. Circle or dot? Circle, because I don't have an equal to sign this time. Greater than 1/4, so I shade to the right. Interval. There's 1/4. And my biggest number is infinity. Once again, I had an issue with my camera failing, so I'm going to finish this at home. The last thing we needed to talk about is compound inequalities. And these look something like this. We might have negative 3 less than or equal to 2x plus 1 less than or equal to 9. And the goal here is to do a couple of steps and get the x all by itself in the middle. Well, if I want to get the x all by itself in the middle, I got to get rid of this plus 1, so I do a minus 1. And really the only big difference is I have to do minus 1 in 3 places. Usually when we solve an equation or an inequality, we say subtract 1 on both sides. Well, here we do it in 3 places. Other than that, these problems work pretty much the same way. So I have minus 4 less than or equal to 2x less than or equal to 8. Divide by 2 everywhere. Negative 2 less than or equal to x less than or equal to 4. Number line, I mark down negative 2, I mark down 4. Both of them would get dots because they both have the equal to sign back here, and I shade in the middle. And then finally my interval notation, my smallest number is negative 2, my biggest number is 4, square brackets on both. Alright, last problem. How about minus 4 less than or equal to minus 3x minus 1 less than or equal to 11. How about no equal to on that one, just to be different, just a less than the 11. Alright, so we add 1, and again we have to do add 1 everywhere. I get minus 3 less than or equal to minus 3x less than 12. Divide by negative 3. Now this is slightly different. When we divide by negative 3, we got to flip our signs, and since we're dividing everywhere, we got to flip all of our signs. We have 1 less than or greater than or equal to x greater than negative 4. When I draw my number line, when you draw your number line, you always put the smallest number on the left, that's the negative 4, and the biggest number on the right. Negative 4 gets a circle because it does not have the equal to. 1 gets a dot. That can happen. You can have 1 circle, 1 dot, that's okay. Shade in between. And then finally, interval notation, minus 4, 1. Minus 4 gets a round bracket because there's no equal to there, there's a circle there. And 1 gets a square bracket because there's a dot there and there is an equal to there.